Hello, my name is Joel Creer. I'm a clinical geneticist and a clinical lead on the CGAP development team. And I'm here to share with you a brief tutorial on using CGAP for the analysis of unsolved rare disease participants in the Undiagnosed Disease Network. We're going to use a participant who has consented for full publication of data, and we're going to start by briefly introducing you to the phenotypic features, including history of seizures, intellectual disability, macrocephaly, and sensorineural hearing impairment. And we can quickly check out the family history, which has been loaded into CGAP as well. And we can see here, in addition to our severely affected proband, that the parents are generally healthy. There are some other phenotypes present in the family, and these have all been mapped to human phenotype ontology terms. We can take a look and see how hypertension segregates, for example, within this family, but we can most importantly see that these rare phenotypic abnormalities that are present in our participant are not present in other members of this cohort. Going back to the Bioinformatics tab, we can quickly see some bioinformatics metrics, which we'll get to in a second. But first, I just want to point out that we are informed here that we have whole genome sequencing trio data that has been loaded and run through the CGAP pipeline. And it has produced some selected QC metrics that we can use to assure ourselves that the processing went well and that the data look satisfactory for downstream analysis. This includes metrics like heterozygosity ratio and transition to transversion ratio. And then finally, there's a table which will show us the individuals who've been included in this analysis, in this case, the proband and his mother and father, the source of the samples, and some intermediary files that we can access here if we wish. I'm going to move now to the filtering tab, which is where the exciting functionality for CGAP lives in terms of analyzing these challenging participants who've had unrevealing or non-diagnostic clinical sequencing and interpretation. And so we're going to take a inheritance mode based approach, or sometimes referred to as genotype first, for this filtration. And to do so, we're going to make a few assumptions to help us get started, at least take a first pass. We're going to assume that there are a few inheritance modes that could possibly explain this scenario, including de novo or recessive, including homozygous recessive or compound heterozygous, or especially in this case, given that we have a male proband, X-linked. And so I'm going to just show you how we would create a de novo filter. It's actually quite straightforward. I'm going to select on this filter block that has been placed here. I'm going to name it. And now I'm going to come over to my filter properties, which lives over here on this left-hand side. And I'm going to go to my inheritance mode options, and I'm going to select something called de novo strong, which is the most restrictive de novo filter that's going to pull in variants that have a very high degree of confidence for being correct calls. They would not 100%, but very close. And so this is going to give me a very small number of candidate variants, and that's what I want. So in this case, I pulled up one candidate variant that fits this de novo strong inheritance mode. If I wanted to, I could put some additional filters on. I could, for example, put on a population frequency filter that says I only want to see variants that are absent from nomad. And so I've done that, and this variant still is absent from nomad, so this variant still meets the filtering criteria and is still present. So building these filter blocks is actually quite fun, but it takes a little bit of getting used to. And one way that CGAP has helped to make this even more user-friendly is to allow for saving filter sets. And so you can see here we have something called simplex trio restrictive. And this is a set of filters that I created for the first pass analysis of unsolved rare disease cases. And so I can just, with the click of the button, copy those filters over. I'm going to override the filter that I've created, which is fine. And now I've brought in my filters reflecting multiple inheritance modes, including de novo, homozygous, X-linked, and compound heterozygous. Now, once I've created my filters, I'm going to see that there are a subset of variants that meet my criteria. So I have 16 matches at this point, if I include all 4 of these filter blocks. But I want to just go one at a time. So I want to start with de novo. And by selecting this filter block, it's going to show me only the variant that meets that particular filter block's criteria, which is GDF11. And so at this stage, we can do some technical review to make sure that this variant call looks like it at least may be true, and hopefully is confidently true before we spend more time thinking hard about this gene and this variant. And so I can do that by using this BAM snap functionality, which quickly pulls up a image that's going to show me what the underlying BAM files look like. And I can see here in my proband a variant which appears heterozygous and appears in reads going both directions with little noise around it. So that looks like a really nice call. And it is in fact entirely absent from both the maternal and the paternal samples. So I'm quite confident about this call. And I'm going to click here because now that I've reviewed this and I feel good about the call, I want to make sure that I spend some time interpreting this gene and variant. So I'm going to add it to interpretation. So I've done that now, and I can see that this is grayed out. And I can do that for each of my different filtration modes if I wish. But for the sake of time and demonstration, I'm going to go ahead and move now to the interpretation tab. So once I've selected a variant for interpretation, you might have noticed that this interpretation tab lit up and is now accessible to me. And so I can move over there and I will find my GDF11 variant. You can see actually that we've already done a little bit of classification of this variant, but I'm going to walk through it for the purposes of this demonstration. So first I can click on this, and this will take me to the annotation space and interpretations, and also access what's called the interpretation space over here on the right. So the gene tab is going to provide me some information about the gene. It's going to pull in some information from RefSeq and provide me a bunch of links that I can use to quickly hop in and out of CGAP to learn more about this gene. So if I wanted to, I could look at gene cards and look at some other information that's been pulled in from various sources. I could go to OMIM and see if in fact there has been a disease associated with this. And there is one possible association that has been described. And I can look at RNA-seq data if I wish, for example. And then I can also look at the constraint metrics from NOMAD, which can be quite helpful for the purpose of identifying novel gene disease associations. And I can see here quickly that this has is relatively constrained for loss of function variation, as well as missense variation with an LOEUF below a cutoff that we like to use of 0.35. And so this is all very intriguing at the gene level, makes this a potentially interesting gene in which to find an impactful variant. And now I'm going to turn my focus to the gene and to the variant, but I have already previously made some notes here, which have been saved in CGAP, telling me a little bit about this gene. It's highly constrained and it's conserved in various organisms. I can go now to the variant and confirm that it is both absent in NOMAD exomes and genomes. I can find out that it is a stop-gain variant. I can actually look at different transcripts if I wish to see what the effect is. And then I can also pull in some helpful metrics here showing me that it has an extremely high CAD score, for example. And once I've done that, I can certainly make my variant notes and save those. And then if I wish, we've kind of created these categorizations, and though these are certainly customizable in the future, and I can decide that this is a strong candidate, moderate candidate, weak candidate, or not a candidate at the variant level and at the gene level. And at both levels here, we feel this is a very strong candidate based on what we've learned, and I can save this, and now it has been saved to the interpretation space for my project. I can now go back to my interpretation space, and I can do this again for the other variants that I have selected, or I can go back to my filtering and find more variants that I want to do interpretation on. And once I've done that, and in addition to focusing on SNVs, which is the focus of this demonstration, I can certainly go back and do the same for structural variants using the structural variant tab, which is demonstrated in a different educational video. But once I've done all that, I can now go to my case review, and I can begin to make some more detailed notes on this variant, and then ultimately prepare for a report if that's something that I want to do as part of my project's workflow. And so I can create some notes. I can decide if I want to send this to the report. I can customize my notes or modify my notes in preparation for a report if I wish to do so. So that is a quick demonstration of a workflow for the analysis, filtration, and interpretation of a proband with an unsolved rare disease. And I hope it was educational to you and got you excited about the functionality and opportunities for efficiency within CGAP. And I will also mention that, of course, this approach does not always work, does not always identify such a strong candidate. And in that case, you can go back, for example, to the filtration and create other filters to broaden your net, for example, broaden your search based on a gene, or perhaps broadening filters to look at non-coding variants like UTRs or other variants that may have been missed by that very restrictive first pass that I utilized. Thank you very much.